Today we're going to learn how to build interactive, impressive data dashboards in Python using Tkinter. So let us get right into it. So my goal for this video today is to show you how to build impressive data dashboards using Tkinter in Python. And what I'm going to do for this is I'm going to show you two simple examples that we're going to code from scratch. And then I'm going to show you some more advanced examples. You're going to get the code for them, but I'm not going to code them live in this video today. So a basic example that we are going to code is this one, a very basic data dashboard for the Titanic data set. We can choose a column here. We can change between or switch between two columns. A more advanced version of that would be this one. This is now an analytics dashboard with analysis of the data. I think maybe if I turn this into full screen and back, the glitch is gone. We have a correlation heat map. We have age distribution, survival analysis. We have some statistics here. We can filter by age. We can filter by gender and by class and so on. So all of that can be done. We can also export. This is a more advanced version. Then we have a basic stock ticker visualization or stock price visualization here using candlestick charts. That would be for the Apple stock price. I can also go with Microsoft, for example, and get some other data. I can also adjust the time frame. This is also something we're going to build in this video today. And then we have a more advanced version. I'm going to provide you the code, but we're not going to code it from scratch. This is with technical analysis. So we have here some indicators, some Bollinger Bands and simple moving average, exponential moving average. We have technical analysis here in a separate tab as well. We have some fundamentals here with market cap, PE ratio, and so on. We can also simulate a portfolio here in terms of we can add different shares, for example, Microsoft, load data, and then I can say 5 shares of that. Now you can see I have some Microsoft, some Apple, and then I can also compare stocks here like this. So that is what we're going to talk about today. Again, we're not going to build this here from scratch, but we're going to see how it's done in general, and then you can look at the code and see how you can do it in a much more advanced way. That is the plan for this video today. All right, so let us get started with the coding now. I'm going to open up my terminal and go to my tutorial directory. And in here, I'm going to initialize a new project with a virtual environment. Now, you can install the packages that we're going to need for this video today however you like. The most basic way is to use pip or pip3 install. And then the packages, for the first example, we're going to need pandas and matplotlib. So if you want to just do it in the basic way, you can do it like this. Run the command either pip install pandas matplotlib or pip3 install pandas matplotlib. And then you install the package. Depending on your operating system and installation, you have to use one or the other. Now, if you want to use a virtual environment, you can use venv, you can use virtual env. In my case here, I'm going to use uv. However, it doesn't really matter to you. The only thing you need to make sure is that you have pandas and matplotlib installed. The rest is going to be the same. You just write some code, you execute the code, and that's it. So make sure you have these packages installed. In my case, what I'm going to do is I'm going to initialize a UV project here. I'm going to say UV add pandas and matplotlib, and basically the setup is now the same. I just have this isolated environment. So create a file called main.py. In my case, this already exists. I'm going to delete the code here. So I start with an empty file. And we're going to start now with some basic imports. Now, Tkinter is a core Python package, so we don't need to install anything in order to use it. Just start with a basic import, Tkinter as tk. Let me zoom in a little bit more. Then from Tkinter, we also want to import ttk for some more advanced stuff. And then we're going to import pandas as pd for the data frame handling and matplotlib .pyplot as plt for the visualizations. And now what we need to do is we need to also add a matplotlib backend so that we can connect matplotlib to Tkinter so that we can show the visualizations as part of the graphical user interface that we created with Tkinter. So we're going to say here from matplotlib.backends.backend underscore tkagg, which is not aggregation. What this stands for is anti-grain geometry, which is, I think, a framework or a backend for, I don't know actually for what it is. I think for some sort of visualization, but that is what AGG stands for. We're going to say from that import figure canvas a or actually TK AGG. Now, before we can just move on with the coding, we need to make sure that we have some data that we want to visualize, something to base our visualizations on. In my case, I have here a Titanic.csv file. You will find a link to it in the description down below if you want to use the same data set. It's a basic Kaggle data set that you can easily download and use. It contains some information about passengers like the age or the name and whether they survived or not. So this is a binary 0 or 1, and that is a data set that we're going to visualize here. You can of course choose whatever data set you want. Just make sure that you adjust the code accordingly, file names, column names, data types, and so on. But you can use whatever you want. We're just going to refer to some of these columns. We're going to have some options so that we can switch between different columns. And yeah, again, just use the same data set if you want. You will find a link to it in the description down below. Otherwise, use whatever data set you want and adjust the code accordingly. So what we're going to do now is we're going to model our application as a class. I'm going to call this class simple dashboard, and we're going to have a constructor and a init method, which takes self as an argument and also root as an argument. So the root TK instance. And what we're going to do is we're going to say self.root is equal to that root that is passed to the constructor. And then we're going to say self.root.title. Let's call this simple data dashboard, and then also self.root.geometry, and we're going to go with 1000 times 600. Next, we're going to load the data set, so we're going to use pandas to say pd.read_csv, and we're going to pass the file name, the Titanic.csv file. This is going to load the data set as a pandas data frame, and then we're going to use that pandas data frame for Matplotlib visualizations. These two packages are very compatible, so it doesn't take a lot to visualize these values. And now we're going to also create a frame to put all the different components into. So we're going to say here control frame is equal to TK frame, which is part of root. And then we're going to say control frame pack, and the padding Y is going to be equal to 10. Next up, we want to allow the user to select a column. So we want to have a label that says here you can choose a column name. Then we want to have a drop down, and we want to put all this into the control frame. So we're going to say here TK label, which is part of the control frame. So that's the parent element. The text is going to be equal to column. And then we're just going to say pack side is equal to TK left, which is a constant. Now, what we also need now is a string variable to keep track of what column is selected. We're going to make this part of the class or of the object, and we're going to call this column underscore variable, which is going to be a string variable. And the default value of that string variable is going to be h. So that is going to be the default column. And now what we're going to do is we're going to have a drop down that allows us to select different columns, and we're going to make this column variable here change depending on the selection. So I'm going to say combo for combo box, which is the drop down, is going to be equal to ttk.combobox, which is going to be part of the control frame. So that is the parent element again. Then we have a keyword called text variable, and text variable is going to be equal to the not control frame, sorry, self.columnVar. And then we can specify the possible values as a list. We're going to keep it simple here. We're going to just say age and fair. So just two columns. Again, customize this however you want. And the width of the whole thing is going to be 10. So that is a basic dropdown. We're going to be able to switch between age and fair as the columns here. And this is why we need this string variable to keep track of that, to have it also as an attribute of the object. And this combo box here is the dropdown that allows us to choose something. Also, of course, we need to pack this. So we're going to say combo pack side is equal to TK left as well. And then padding X is going to be equal to 10. And now what we need to do is we need to bind an event to this combo box, because the moment I change my selection, I of course want to also update the charts. So when we have all the charts, we need to make sure that whatever is shown there is consistent with my selection. So when I change from age to fair or the other way around, the chart has to update. So what we're going to do is we're going to define a method here, which we're going to call update charts, and it's going to have a self keyword. And this is what we're going to call when we make a selection in the combo box. So I'm going to say combo bind And the event is called, we use two angle brackets, opening and closing, combo box selected is what the event is called. And we're going to bind that to self.update charts. Now we also need to have an event here. So event is going to be equal to none. That is how it works. So by selecting something in the combo box, this method here is going to be executed or called. So what we now also want to do is, in addition to our control frame that contains the components for controlling, in this case just a basic column selection, we also want to have another frame which is for the chart. So we're going to say here chart frame is equal to TK frame, which is also part of root. And in this chart frame now what we're going to do is we're going to place a canvas and it's going to expand, so it's going to fill the entire space. And we want to make sure that we have 4 subplots in there that visualize different parts in a different way. So we're going to say chart frame dot pack. We're going to say fill is equal to TK dot both. We're going to say expand equals true. We're going to say padding X is equal to 20 and padding Y is equal to 10. So that is just some styling stuff. Basically what we do with this is we make sure that the chart frame fills the entire space. So when we resize the window, we still have the entire space filled with the chart frame. And in this chart frame now, what we're going to do is we're going to define figures and subplots. We're going to have this figure canvas here from the backend of Matplotlib. And then we're going to put that into the chart frame. So let's create the subplots. We're going to say self.figure and then all the axes. So we're going to say here in parentheses and then also here in additional parentheses, we're going to say self.axis1, self.axis2. Then in the second set of parentheses here is self.axis3, self.axis4. That is basically because we have a grid, a 2x2 grid, and we're gonna get all of this, so the figure and the axes, by saying plt.subplots, and we can specify 2x2, so 2, 2, and figure size is equal to 12, 8. So this basically returns all of that. Now when we plot on self.axis1, we're going to get the visualization in the top left. Here we're going to get it in, I think, the bottom left, and here top right and bottom right. So as of right now, we didn't add this yet to our user interface. We just have the figure and the axes outside of our application. To add this to our application, we need to use the backend from Matplotlib here. So we need to say self.canvas is equal to figure canvas tkagg. We're going to pass here the figure as the first argument and the chart frame as the second argument to place this canvas inside of the chart frame with the figure as the content. And now in order to pack this, we cannot just do self.canvas.pack. We need to actually get the TK widget using a method. So we're going to say self.canvas.get underscore TK underscore widget. I think this was the function name. Yeah. And then pack fill is TK both and expand is true. And the last thing that we want to do is self.update charts manually called at the end here. Why? Because of course it is called every time we change the selection, but of course in the beginning we have H as default. We also want to show the charts not only when we change the selection, but also when we load the application. So in the init method here in the dunder, we call self-update charts as well. And the rest is now just basic Matplotlib visualization. So if you know how to use Matplotlib, if you can create visualizations in Matplotlib, you can now do whatever you want also in Tkinter. So you can just go down here and you can say, do something here with Matplotlib. And in the end, all you have to do is you have to say self.canvas.draw. And everything you do is going to be drawn onto the canvas. So now you can customize your dashboard however you like. In our case here, we're going to say get the column that was selected. So self dot, what did I call it? Column variable or column var. So self dot column variable is what we get as a column here. In order to get the actual value and not just the variable itself, we need to say dot get to get the string value. And now we're going to base our visualization on that selection. For the first visualization, however, we want to do something independent of this column. So we're going to say here self.axis1.clear to reset everything. and we want to plot the survival rate as a pie chart. So we're going to say here, survival is equal to data frame. Actually, did I call this self.dataframe or did I just say data frame? We need to say self.dataframe, otherwise I cannot access it in this function here or method. So we're going to say self.dataframe, and in here now we want to get the survival column. So I think it's called either survival or survived. Survived, and from this one we want to get the value count. So we want to just have a pie chart showing how many people survived versus how many people did not survive, unfortunately. So we're going to say self.axis1, give me a pie chart based on survival.values. The labels that we have here are going to be not survived and survived. And then we're going to say auto PCT is equal to percent 1.1 f%%. That's just the formatting, so we see the percentages as numbers as well. And then I'm going to say self.axis1 set title survival rates. So that is now in the top left corner. This is going to be a visualization independent from the column we choose. The second one is not going to be independent. So here we're also going to say self-axis to clear just to make sure we reset every time. And in this one, I want to plot a basic histogram of the selected value of the selected column. So axis to histogram, we're going to say self data frame, whatever column was chosen. Bins is going to be 20. Color is going to be sky blue. And transparency, so alpha is going to be 0.7. The title for that, let me copy this, is going to be, oh, actually there is an additional S here. So the title is going to be whatever the column is, distribution. All right, so H distribution, actually, of course, this needs to be 2, H distribution or fair distribution. For the third visualization, we want to have something general again. So self-axis3.clear. We want to have a bar chart of the different passenger classes. So how many people belong to which class? I think there are 3 classes and the column name is P class. So we can just say here self.axis3.bar, and we're going to say self-df P class, then value counts sort index. Or actually, to make this easier, let me go to the beginning. Let me delete all of this. Let's say classes is equal to that. So we can do this without writing this twice. So self.axis3 bar classes index to have the names on the x-axis basically. Then classes values to have the height on the y-axis. And then the colors are going to be red, green, blue. Quite simple, quite straightforward. Then self.axis3 set title passenger classes. Let's do it like this. For the last visualization, I want to do something a little bit more fancy, which is I want to visualize the chosen column for passengers depending on whether they survived or not in different colors and with different labels. So what we're going to do is we're going to say self.axis4 clear, and then I want to say, then I want to say for survived in, and I'm going to provide 0 and 1 here as values. And then basically I want to say subset is equal to data frame or self.dataframe, where self.dataframe survived is equal to whatever the current value is. And then we're going to do a scatter plot. So we're going to say self.axis4 scatter, and we're going to scatter the values of this subset. Again, the values means the column that is selected. So we're going to say here subset column, where actually we need to plot 2 values. So, okay, it doesn't make a lot of sense, but let's go and say subset column and subset fair. Now, what this means is that if I select fair, it's going to be just a straight line because it's going to be the same values. So not very interesting, but still, let's just do it here for the sake of demonstration. You can change this however you like. But essentially here, we're going to plot these 2 values. And the interesting thing is we're going to say that the label and the color are going to depend on whether the person survived or not. So we're going to say label is equal to survived if survived, else not survived. And the alpha is going to be 0.6. I think the color should be changed automatically. I don't think that I have to provide it here explicitly. I think this should work automatically. Then I'm going to say here self.access4 x label, which is going to be the column that we chose. I'm going to say y label, which is always going to be fair. Then the title is obviously going to be a formatted string showing column versus fair. And then since we had labels, self.access4 legend, and finally the whole thing should have a tight layout. So self.figure tight layout, and this will then make everything fit together easily. The final thing that we need to do is we need to have a section here if underscore underscore name underscore underscore equals underscore underscore main underscore underscore. Then what we want to do is we want to say tk as the root element, the root instance. The app is a simple dashboard given the root, and then root.main loop. Super simple. If I didn't make any mistakes, that should work perfectly. So let's, in my case, do uv run main.py. In your case, if you're not using uv, just do Python or Python 3 main.py. And in this case now I have a problem. Okay, so I think this was mainly a problem because I pinned the version to 3.11 and my installation of TK is on 3.13. So this is some Linux stuff, probably doesn't apply to you. But we have another problem, which is string var doesn't exist, obviously because we need to call this tk.string var. So we need to go back into the code, and I think it's either tk or ttk. No, it's tk actually. So tk.stringvar, and let's see if that works. There you go. But we had a problem with sort index function. Object has no attribute sort index. Yeah, I think because we're not calling value counts, but we're just referring to it. So we need to say value counts like this. Run this, and we have another problem, which is X label doesn't exist. I think this is because it should be called set X label when we use axes, and set Y label. But now that should be it. There you go. We have our visualization. Here is our survival rate pie chart. We have the passenger classes as bar charts. We have our fancy H versus fair scatter plot with different colors and labels, and we have our H distribution here in sky blue. You can see here when I use fair versus fair, it's not very interesting, but you can see how some of the charts change, these two to be precise. That is a minimalistic example. A more sophisticated example here would be this one, main2.py. As I said, I'm not going to code it here because it would take too much time, but that is an advanced version where we have more options and different tabs. I do have a bug that you probably won't have on Windows, or if you're using not a tiling window manager, which is the glitches with the graphics. But here you can see we can explore the data. I can also search. I can say, for example, here different names. Both of them survived. That's great. Then we have here some heat map, survival analysis, H distribution, fair analysis, some overview. We can change here the different classes and all that. You can take a look at the code if you want to. I'm going to show it briefly so you see what it roughly looks like. The idea is the same. We don't have any more fancy imports. We just have a message box and a file dialog. But besides that, it's just some styling. It's just, again, some buttons and some tabs and combo boxes and everything packed together. It's the same principle with a bunch more UI elements with more customization in terms of Matplotlib. Of course, this takes more time, more customization, but the idea is the same. You can just build dashboards by doing Matplotlib stuff and by embedding it into the backend, which is this figure canvas tk HEG. All right, so let us build now the second example, the second simple example, and then I'm going to show you again a more sophisticated one. We're going to open up a main.py file again. Now this time, actually, before we do that, we need an additional package. We don't need pandas anymore, but we do need yfinance because we're not going to load the data from a CSV file. We're going to load it from the Yahoo Finance API. So in this case, you have to run pip or pip3 install yfinance, or in my case, uv at yfinance, and then main.py. And here now we're going to do roughly the same imports. We're going to do some small changes. We're going to say import Tkinter as tk. I'm going to say from Tkinter import message box. So we're going to have a pop-up this time. Then import yfinance as yf. Import matplotlib.pyplot as plt. Then import matplotlib.dates as mdates, common alias. And then finally again from matplotlib.backends.backend tkagg import figure canvas tkagg. So this one is going to be a stock data visualization tool. We're going to provide a ticker symbol, a start date, and an end date. And then we're going to visualize a candlestick chart based on this information. For that, I'm going to create a class called candlestick chart. And we're going to have an init method again with self and root. We're going to do the basic stuff like self.root is equal to root. Root.title is equal to stock visualization tool, or whatever you want to call this. Then actually not root, but self root title, self root.geometry. And then you can specify here again the size. I'm going to go with 1200 times 800. And then now to make this dark mode, we're going to say self root.configure, and we want to configure the background to be the following color code, a dark gray, which is 2B, 2B, 2B. Feel free to adjust this if you want to have different styling. And then we're also going to say PLT style use, and we're going to use a dark theme, which is I think one of the very few dark themes that are available in Matplotlib by default, which is the dark underscore background. Then again, we need some basic control frame. In this control frame, we're going to have the 3 entry boxes. So for the ticker symbol, the start date, the end date, and also a button that actually loads the data. So we're going to say here self.control frame, and it's going to be part of root. It's going to also have a background. We need to keep the styling consistent. So the background is going to be equal to 2B, 2B, 2B. And we're going to pack again. We're going to say padding on the y-axis is equal to 10. And then now we're going to add labels and entries 3 times in a row. We're going to do that with a grid layout so we can place them properly. We're going to say tk label part of self control frame. And this is going to be stock ticker. Font we're going to use is a tuple, Arial, and font size 12. Background, not surprising, is going to be 2B, 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 and the foreground is going to be white. Now to place this directly, we're going to say grid, because we're not going to store this in a variable. We're going to say grid here, row is equal to 0, column is equal to 0, and the padding on the x-axis is going to be equal to 5. That is the label. Following this label, we want to have a text box, so an entry where we can provide the ticker symbol. But for that, again, we need a string variable. So I'm going to say here self.ticker variable is equal to tk string variable, which is going to have a default value of Apple, let's say. And then we can say ticker entry, and the ticker entry is going to be a tk entry, part of the control frame, like this. The text variable associated with it is self.ticker var. The width is equal to 10. The font is again a tuple, Arial, font size 12. Now the color here is going to be different. We're going to say the background color here is going to be a little bit lighter. So we're going to say 404040, which is still dark gray, but a little bit brighter. But the foreground is still going to be exactly the same, white. Just so we have some difference between the background of the text box itself and the background of the whole application, so we see the boxes clearly. And then we also want to say insert background equals white. That is our entry, and now to place it, we need to use the grid method again. So we're going to say ticker entry dot grid, and here we're going to say row is 0, column is 1, 1 means 2 in this case because 0 means 1. And then padding x is going to be 5 again. Now we can actually just copy this and do this 2 more times. So we have this here again, label, variable, entry. Label, variable, entry. Only thing we need to do here is now change that to start date. That can stay the same here. This now is the start variable, and we can do something like 2023-0101. That's the format of the date, year, month, day. Now for the ticker entry, we're going to call this start entry. It's going to be part of control frame. The text variable is going to be the start variable. Besides that, we can keep everything the same. Start entry grid. Now this time here, it's going to be actually here as well. We need to say column 2 and column 3. And then here we need to do the same thing with the end date. Actually, maybe let me just copy. What did I do now? Let me actually just copy this one because I just have to change start to end. Start to end. Start to end, start to end. And besides that, also, of course, the columns. So here we need to have 4 and 5. I think if I didn't mess up something, of course, here we need to have a different date. And here, of course, also end variable. I think that should be it. Not sure. Let's look for start. Yeah, looks good. And let's look for ticker. Also looks good. So these are now our 3 boxes. We also want to have a button, a load button. So we're going to say self load btn, or actually we don't need self because we're not going to use it anywhere. Load button is tk button. The button is going to be part of the control frame. So we pass it here again as the parent element. The text of this button is going to be equal to load chart. The command is going to be a method that we don't have yet called load chart. So let's just define it here as a placeholder. Load chart self pass. This means that clicking this button is going to call that method. And then we do some styling stuff again. We say here in this case for the button, the background of the button is going to be 4CAF. I'm just copying the color code here from my prepared code because I think it looked decent. That is the background. The foreground is going to be white. The font is going to be a triple this time because we're going to have Arial, we're going to have 12, but we're also going to have bold for the font weight. And then the padding on the x-axis is going to be 20. And this button now needs to also be added to the grid. So I can just copy this. I can paste it here. I can replace this with a load button. And of course, we want to set this to column equal to 6. The padding can be set to 10. And that should be it. The only thing missing now, of course, the most important part, since we're building data dashboards, is again this component here, this figure canvas that is going to allow us to display the visualization. So we're going to say self.figure, self.axis is equal to plt subplots. This time we're going to have just a single plot. So we're going to say figure size is equal to a tuple. The tuple is going to be 12.6. This basically means we just return a single axis. We don't have 4 axes as before. We just have a single one. And now we do the same thing. Self canvas is equal to figure canvas tkagg self.fig. And then actually I forgot to create a chart frame. So a chart frame as before, the chart frame is going to be equal to a tk frame, which is part of self.root and has a background, of course, of 2b, 2b, 2b. And then chart frame pack, fill is tk both, expand is true, same reasoning as before. And then padding x is 10, padding y is 10. So here we provide now the chart frame, and then finally self.canvas dot, what was it? Get tk widget. I don't have auto completion here, which is a bit annoying. I need to fix that. fill is equal to tk both, expand is true. And finally, self-load chart, same reasoning as before. We want to have a default chart. So when we run the application, we want to see the Apple stock price already visualized. And now, of course, the whole Matplotlib magic happens in this function. We can also define a helper function here, create candlestick chart, which we're going to call self. And for a given ticker, we want to have data and ticker. I'm going to use that, and load chart is going to do the following. It's just going to retrieve the information and it's going to pass it to this function. So we have it a little bit more modular. We're going to say try. We're going to get the ticker from the string variable self ticker var get, and we want to make this upper. Not sure if that's needed for the Yahoo Finance API, but let's just do it. And then for the start date and the end date, we're going to do the same. Start date, we don't need upper though. So actually I can just copy this, and I can do it like this, and I can do it like this. There you go. So start date, end date, ticker, we have these values, and now we can just retrieve the data. Stock is equal to yfinance.ticker. That is going to be just passing ticker, and the data is equal to stock history, and we're going to pass start is equal to start date, end is equal to end date. And the only thing we want to check is if data is empty. So if we don't have any data, we want to show an error. Message box show error. We want to say error, no data found. That's it. Return. Otherwise, we want to call the self create candlestick chart function with data and ticker. And if any exception occurs, exception as E, we just want to show it. Message box show error, error, and then just error, and then STRE, the exception. All right, that's it. And the visualization now happens here. This is now just candlestick chart. So we're going to say self.axis clear to reset everything if it exists. And then we're going to just get the values for the candlestick chart. For those of you who don't know how it works, it's basically a candle. It can be green, it can be red, and it has a bunch of values. So it has this very thin line in the middle, which is like the max and the min value. And then we have the open and the close value. Open and close value. We have high, open, low, and close. So the top point of the thin line is the high. The lowest one is the low. And then you have like the actual candle, so to say, which is the green or red part. And depending on whether it's green or red, you have the close at the top and the open at the bottom, or the other way around. So if it's a red candle, it means that the price is lower than in the beginning. So it opened higher and closed lower. That would be a red candle. So the opening price at the top, the closing price at the bottom, and vice versa if it's green. So what we're going to do is we're going to say dates is equal to data index. And then we have opens is equal to data open, and then let's just do it here with close. Let's just do it here with close. Actually, closes to be consistent. Then lows is equal to data low, and highs is equal to data high, like this. You can, of course, also use square brackets to access the values, but that is what we do here. Now we need to determine which of these days were up days and which of these days were down days. So to know how to color them, either green or red. And up days are just days where the closing price is greater than the opening price, because that means that the price went up. So we're going to say up underscore days is going to be equal to closes greater than or equal to opens. And the down days are going to be the opposite, where the closes are less than the opens. So quite simple. Then we need to define the widths. We're going to have two widths because we have the colored area, which is a little bit thicker, and we have the very thin line. So we're going to have width is equal to 0.6, and then width 2 is going to be equal to 0.05. And then the up color is going to be defined as a green color, so 26A69A. And the down color is going to be equal to a red color, EF5350. So now comes the interesting part. How can we actually create candlestick charts in vanilla Matplotlib? Of course, you can also use an external package for that if you want to keep it simple. We're just going to combine 3 bar charts into a candlestick. The idea is quite simple. We have the colored area and we have the 2 thin lines. These are 3 bar charts that we can just put together. The idea is on an up day, we have the opening price at the bottom and the closing price at the top. So the bottom of the first bar chart would be the opening price, and then we have the difference between closing price and opening price is the height of the bar chart. And then we do the same thing for the minimum and the maximum for the high and the low value for the thin lines. And then we have a candlestick for a particular day, and we can do that easily just for all the days. So what we do is we say self.axis bar, and we say here dates on the x-axis for the up days. So these would be now the green candlesticks. And the height of the bar, as I said, is going to be the closing price. Since we have a winning day, the closing price of the up days minus the opening price of the up days. And the bottom, or actually, first of all, let me pass the width. And the bottom, so the basis for that is going to be the opening price. Again, starting at the opening, going up until the close price for the up days. Like this. Then the color is the up color. And alpha is going to be equal to 0.8. That is the colored area, so to say. So let me just maybe format this in a better way, like this. Then we need to have the thin line. So we're going to say self.x.bar. Dates is going to be the same. Up days. But now we need to have these 2 thin lines. We're going to say for the first one, we want to go from the closing price to the high. So we're going to say highs, up days, minus closes, up days, width 2. The bottom here obviously is going to be closes, up days. Color is going to be, actually we're just going to go with up color here as well. Usually I think they're gray, I'm not sure. But that is that. And then actually no alpha because we want to actually see them and they're already quite thin. So let's copy that. The other one is obviously going to go from the lowest point to the opening. So we're going to say here dates up days, and we're going to go here from opens to lows, and we're going to start at lows. That's that. And actually, of course, this is not up days, but up color. All right, so that is for the green candlesticks. We can do the same thing now for the down days. We just have to replace a couple of things. I'm gonna just use substitution here. I'm gonna say from up days, I wanna change all of them to down days, like this. And then from up color, I also wanna do the same, up color, down color. And of course, we also need to change the values though, because on losing days, the order is different. Then we need to say here from opens to closes. And this is closes. Actually, we're missing an S here. Those closes, there you go. And we have a down color, that's great. And now here for the thin lines, we also need to make sure that we have high, but the high value is actually the open value. So we need to say here highs, open, and then opens. Actually, again, forgot an S here. And then here we have closes, lows, and lows should be the same. And the rest is now just basic styling. Self.axis.setTitle is going to be formatted string. Ticker. Do I have a ticker? Yeah, I have the ticker. Stock price, whatever. Then self. Actually, let me make this a little bit more beautiful. Font weight is equal to bold. Font size is equal to 16. Padding is equal to 20. Then we need the labels. So axis set X label, price in USD, and then Y label. Actually, no, the Y label is the price. That is the date. Let's go with a font size of 12 here. And let's also add some formatters for the date. So self.axis.x-axis set major formatter without the double P's formatter. And we're going to say mdates date formatter. We're going to pass y-m-d so that we have year, month, day. And then self.axis, x-axis, set major locator, mdates month locator to make this more concise. Then self.figure, auto format, xdate, self.axis, grid true, but we want to have it quite transparent, so 0.3. And then finally, self.figure, tight layout, and most importantly, self-canvas draw to actually see something. And I'm sure we made some mistakes, but all we need to do now is we need to say this main section here, root is tk. What did I call it? Candlestick. Let's say app is equal to candlestick chart root, and then root main loop. Let's see if that works. I would be surprised if it does first time or first try. There you go. We have a problem. Control frame doesn't exist because probably I didn't use self for it. Control. Do I actually need self control frame? It doesn't matter if I need it. I should be consistent with it. So we have a self here. And now we have another one, or is it the same one? We have line 20. Oh, got it. We need to, of course, okay, got it. We need to say self-control frame is equal to tk frame. Then we have pack doesn't exist. Self.pack doesn't make a lot of sense. I feel like I'm losing my brain cells when I'm recording. And now we have another problem. Start date doesn't exist, okay? Where is the start date? Start date is equal to self start date get, but this is actually start variable, of course. Let's see if that works. And now we have it. There you go. We have this application here, AAPL, MSFT, load NVDA. There you go. Let's go with something like 2018 up until 2024. We should get some more data. Okay, the dates are a bit messed up now, but you can see this visualization tool works. And now, as promised, a more advanced version, UV run main4.py. That is what you can do with that if you put some more time and effort into it. This is like technical analysis already. We have here some indicators. I showed that in the preview already. We have some key metrics. Again, this is just a glitch on my operating system here with the white stuff. I think you shouldn't have that. We have the fundamentals. We have portfolio that we can work with, technical analysis here. And as I also showed you, we can compare stocks in a separate window here. Yeah, this is how you can do this. You can also take a look at the code. You will find it at the link in the description down below. This is more advanced, but again, it boils down to the same ideas. We have the backend. We actually have another backend here for the navigation toolbar, but essentially it's the same idea, just a bunch more code, and more calculations, more technical analysis stuff. But the principle is the same. So now you know how to build data dashboards in Python using Matplotlib and Tkinter. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.